Paired sample t-test. Paired sample t-test is used whenever we have dependent samples. If the samples are dependent, then we have to switch to the paired sample t-test. The independent sample t-tests were done by the two procedures, pooled non-pooled, and the paired t-test is used whenever the samples are related to each other. The examples of the paired sample t-test is like slimming center. The participants join the center. At the time of joining, their weights are represented by x1, and after 1 month therapy, the weight after 1 month is again recorded. Participant number one, the original weight at the time of admission, the participant number one time weight after 1 month therapy. Similarly, the second participant weight before joining the slimming club, and the participant two weight after 1 month therapy. And similarly, if suppose I have n number of participants, then the nth participant weight at the time of joining the club, and nth participant weight. These type of observations are known as paired observations. And in what we are interested, the slimming center is claiming that the weight after 1 month therapy will be significantly smaller. So if the weight is smaller, it means H1 will be what? H1 will be the mean 2 is significantly smaller than mean 1. These types of scenarios are referred to as paired sample and dependent sample, and paired sample t-test will be used to solve this problem. What are the assumptions? Assumptions are simple random paired sample, or we can call it a simple random dependent sample. We can also use the term paired sample, or we can use the term dependent sample for this dependent sample. Repeated measure is also a case of dependent sample. The repeated measure, if repeated measure is done by the 2 times, this is also referred to as repeated measure, because same participant is measured at the time of admission. The participant will again after 1 month repeated. So that is why we can call it as a repeated measure as well. H0 and H1 are same, alpha is same, formula of T statistics is changed. This formula of T statistics is just similar as the formula of T2. What was the T2? In the procedure T2, the X bar minus mean divided by S upon N root. So you can see this formula is exactly same as the formula of t-test we discussed in chapter number 9. This was procedure number T2, second testing procedure. That is why I use T2 here, but T2 is nothing. It is basically a T statistics or the T score. You can compare these two formulas, are exactly identical. Mean is not there. Instead of X bar, I have D bar. What the D bar is? D bar is the difference between the two samples. Suppose these are the two samples, and D can be computed by just X bar, X1 minus X2. X1 minus X2. This is D. So instead of checking the data of X1 and X2, both columns, we will check the only one column. That column is the differences. So that D is the column, the mean of D is needed. Mean of D will be what? Mean of D will be the mean of this column. So you can calculate the mean of this column by just adding all the values of D and then divided by N. So D bar will be computed. Similarly, the standard deviation of these differences will be computed. So the two descriptive measures are needed. One is the mean of variable D, other is the standard deviation of variable D, and the normal differences we have. Normal differences means what? If we plot these differences on a probability plot, so the probability plot will be linear. So we can say that the difference, if the differences are linear in nature, so we can say that the two populations are also be normal. The assumptions will be fulfilled. So this formula and this formula are exactly identical. The mean is not here. The reason is difference of two mean is zero. So if I am substituting the difference here, because this is the difference, so that difference will be zero. Only the mean, sample mean. The sample mean is represented by D bar. Sample standard deviation, here the sample standard deviation is represented by standard deviation of the differences. And similarly, we have n in denominator. This is the critical region approach, this is the p-value approach, and all the rest of the things are exactly same. If the p-value is less than equal to alpha, reject the null hypothesis. Otherwise, do not reject H naught. So this is one complete procedure. This procedure I refer to as T6. Now one complete example will be solved by using this procedure. Paired sample t-test, ages of married people, the husband and the wife, ages of husband at the time of marriage, and the wife, age of wife. The two columns we have. Here we have the age of husband at the time of marriage, and at the time of marriage, the age of women. Similarly, the second couple, the nth couple. The n couples we have, and the both ages will be there. That is why we can call it as a paired data. The paired data can be solved by using paired t-test. The 10 married couples in US are selected at random. So these are the random samples. And the ages and their differences in year of the people chosen recorded in the table on the next slide. This is the table. At the time of marriage, the husband was of 59-year-old, while the wife was 53-year-old. This was the two young couple. The husband age was 21 and the wife was of 22. So we can see here generally the ages of husband are slightly higher in sample as compared to the wife. The differences are computed. D, 59 minus 53, 6-year difference. 1 year difference in negative means the husband has a smaller age as compared to the wife, and so on. Mean of the differences can be computed by D bar is a simply summation D divided by N. And N is 10 in this sample. 3.6 is the mean. 36 divided by 10 is the sample mean. The 3.6 here is the difference. Standard deviation of D can be computed by SD 1 upon n minus 1, because this is the sample standard deviation 1, summation D square, difference square, minus summation D whole square divided by n. Summation D whole square divided by n. This is the formula of sample standard deviation, but this formula is written here for the variable D. So in this under root of this, because I wrote here the standard deviation. So these two descriptive measures you can calculate yourself by using this data set, and then assumptions are to be checked. As normality assumption, these differences are plotted on the straight line, on the normal probability plot. You can see that the straight line of these points indicating the normality. So the differences are normally distributed means the variable x1 is normally distributed, as well as the variable x2 is also normally distributed. So we have to check at 5% level of significance that mean age of married man differ from the mean age of married woman. Differ means H1 we have not equal to. In H1, we have not equal to. In H0, we have equal to. The null and alternate hypotheses are there. Assumptions are checked. Assumption number 1 is satisfied. We have a simple random paired sample. Each pair consists of the married couple. The 10 couples we have, the sample size is small. We have to check the normality by probability plot that we have already constructed. Uh, Two assumptions are fulfilled, then t-test is to be used. T-test is d bar upon sd upon n root. D bar is 3.6. Standard deviation, as I wrote there, d square, total of d square, total of d whole square upon n divided by n minus 1, and a square root of that. 4.9 is the sample standard deviation of the differences, and 3.6 year. The unit of these two measures are in year because the ages are in year. The t statistics is computed, and the value of the t statistics, it is t observed because this is computed from sample. The t observed is 2.291. Now we have to obtain the t critical by critical region approach. So the key T critical two-sided because not equal to we have in the alternate hypothesis. Alpha by 2 is 0.025. T statistics with 9 degree of freedom. So DF is 9 because in paired sample we have a degree of freedom n minus 1. Total number of pair, one less than that. So 10 pairs we have, that is why we have a 9 degree of freedom. So at 9 degree of freedom, 0.025 is minus 2.62 and plus 2.62. And our T observed was 2.29. So 2.29 is here, 2.29. Slightly above 2.26. So clearly we can say that the null hypothesis is rejected, and the conclusion that because it is rejected from the right side, so we have to take the conclusion that the average age of males in the couple is significantly higher than the average age of his wife. That is the conclusion. Here we have used the p-value approach. T value T observed 2.29 is surged into the table, and that is against the degree of freedom 9. The value is doubled because we have a two-sided. That value is 0.0478, which is smaller than 0.05. The null hypothesis is rejected. The conclusion is at 5% level of significance, data provides sufficient evidence to conclude that the mean age of married men differ from the mean age of married women. And finally, we observe the men age is significantly higher than the women age, or the husband age is slightly higher than the wife age. So that is the alternate hypothesis which is accepted in the situation. Up to now, the 6 procedures has been completed. Procedure number T1 for one sample Z test, procedure T2 for one sample T test, procedure T3 for two sample Z test, T4 for pooled samples, and T5 is non-pooled sample, and T6 is the paired sample. These 6 procedures are used. These 4 procedures for two means, and these 2 procedures for one mean. If we have a hypothesis like mean is equal to uh, 50,000, if this is the hypothesis, this can be tested by either T1 or T2. If we have a hypothesis that the two ages are same, so either we can use T4, T5, T6 or T3 depending on the situation. Now in this problem, we have an experiment in which the abrasive wear of the two different laminated materials are compared. 12 pieces of material were material 1 were tested, and the sample of material 1 gave an average of 85 units with a sample standard deviation of sample standard deviation is given, the sample size 1 is given, mean of sample 2 is given, and the standard deviation of sample 2 is given. Can we conclude that this is the statement which is used for hypothesis? Can we conclude that at 0.05 level of significance that the abrasive wear of material 1 exceed the material 2 by more than 2 units? This is the first problem where the difference is given. So this is not the hypothesis in which we are saying that the mean 1 and mean 2 are same. Here we have the difference of two mean is 2 unit and or more than 2 units. So that is a problem that we have to think by which procedure can we can solve this. Assuming the population to be approximately normal with the equal variances, the last statement gives us the opportunity to solve the problem by pool T test. The pool T test can be used to solve this problem. This hypothesis mean 1 minus mean 2 is equal to 2, mean 1 minus mean 2 exceeded by 2, alternate, or alpha is this. T statistics is computed. The T statistics value is 1.75 with the degree of freedom 20. This was the pool T test. Computations are here. The SP is first computed, then the T score is computed. The probability is 0.16. 0.16 clearly stating that the null hypothesis is true. Do not reject H naught. We are unable to conclude that the abrasive wear of material 1 exceed that the material 2 by more than 2. By more than 2 units, this is more than 2 is rejected. So the difference is of 2, which is the null hypothesis, or less than 2. There is a possibility that the difference is exactly equal to 2 or less than 2. That is the alternate hypothesis which is accepted. So this is the list of procedure in this chapter. In this chapter, we have procedure T4, procedure T5, which we have analyzed, and procedure T6. These three procedures we have recorded. These two are the non-parametric Mann-Whitenant test or paired W test. These two tests is not covered in this chapter by me. T4, T5, T6 are covered. You can see all the assumptions are here. Very important slide this is, because it is a summary of all procedures we have recorded in this chapter. Then we have non-pooled standard deviations are not same. Standard deviations are same. Sigma 1 is equal to sigma 2. Standard deviations are not same. Sigma 1 is not equal to sigma 2. Non-pooled and pooled will be decided on the basis of the population standard deviation. These are not the sample standard deviation. I am talking about the population standard deviation. Paired sample will be used whenever we have a dependent sample. So these two are independent samples. This one is the dependent sample. One procedure is not here. That is the procedure T3. T3 is the simple Z test for two means. Is not described here in this slide. This is the flowchart. Starting by initially we check paired sample. If you have a dependent sample, so you have to check whether the differences are normal or not. If the differences are normal, you can use paired t-test. So this is very simple. If we have paired sample and the population are normally distributed, paired t-test will be used. This is T6. If you have independent sample, means not paired, independent sample, so you checked normal population. If the population are normal, Yes, the population are normal. Then you checked equality of standard deviation. If the standard deviation are equal, pool t-test is used. This is T4. If the population standard deviation unequal, then non-pool t-test. This is T5. So T6, T3, T4, T5. If the population are not normal, then next same shape, large sample. Again, if the population are not normal but they are large sample, then again we have to switch either pooled or non-pooled. Similarly, if we have the same shape means sample 1 is right skewed and sample 2 is also right skewed, then we can use Mann-Whitney t-test. Similarly, if the differences are symmetric means like this is symmetric but not normal. This is symmetric but not normal. If not normal but symmetric, then you can use paired Wilcoxon test. Otherwise, if the samples are large, population are not normal, still we can use the paired t-test. The paired t-test can be used in two situations. Samples are dependent, population are normal, or we have a large sample size. So this is the conclusion of this complete chapter, and this flowchart is a very important flowchart. Thank you very much. For some practice problems you have to solve these problems yourself. Uh, 3 problems are here, and that's all.